Dr. Sercel has 3 decades of experience developing advanced technology and innovative products in fields ranging from aerospace and defense to software and robotics. He received his PhD and master's degree in engineering from the California Institute of Technology. He taught systems engineering and space mission and satellite design at the graduate level at Caltech. Sercel is a 6-time NASA Innovative Advanced Concepts Fellowship awardee, has 12 patents pending in the area of space resources utilization technology and in space transportation.
I just want to thank Hillsdale for having me here. They invited me to give a 4-hour seminar in space mining. You guys, the timer is set wrong. It says I only have 20 minutes. So, how do you cover the subject of space mining in 20 minutes? I guess we'll find out here. There we go, my first slide. So a great economist, Neil deGrasse Tyson, said that the first trillionaire ever will be the person who exploits the natural resources of the asteroids. I actually think the first trillionaire will be Jeff Bezos, but the first guy to 2 trillion will be Elon Musk. And they'll both happen in the 2020s. One thing I want to disagree with you, Steve, that continent that's rising up out of the Pacific, the 3 times the size, the land area of Africa, that only constitutes the moon. If you include the asteroids, it's 1,000 times the carrying capacity of the Earth. There's enough resources in the asteroid belt to build beautiful worlds in space that have a carrying capacity of 1 trillion people. That's 1,000 years of exponential growth for our species. And how we start on this new adventure and the next phase of evolution of the Earth as the spawn of the Earth seed space will determine the next millennia. So it's a very significant time. The problem that we have right now getting to space is a problem of transportation. To launch just 1 kilogram, since I'm an engineer, I speak in kilograms, that's 2.2 pounds, into low Earth orbit today cost about $10,000. And using today's transportation systems, if you wanted to deliver just 1 gallon of water to the moon, it would be about $10 million. That's the difficulty we have. The reason for that cost structure is what Steve talked about. It's highly regulated. We're using technologies that really go back to, it's ICBM technologies as the rockets that we've been using. But we're right on the cusp of changing that. Both Elon Musk, Jeff Bezos, and a few others are really developing very cost-effective launch vehicles that will begin to collapse those costs very quickly. What are the resources? What are the primary resources we need to think about as we go into space? Well, you know, the moon is just a few days away, and it's a very significant body. What the moon promises is water and what we scientists and engineers call volatile materials. These are materials that vaporize easily. The great thing about water and the other volatiles that are available now on the moon, and which, by the way, there was no scientific consensus that they existed until very recently. That's what you make rocket propellant out of. That's very significant. That means that when you get to the moon, you can refuel and come back, and that reduces transportation costs by a factor of 10 or more. The moon, you have that. You also have precious metals and the kind of strategic materials that are used in semiconductors, as well as just about everything else you need. The only thing we can't find readily in space is nitrogen. Now, my company, TransAstra, is funded about 2/3 by NASA grants and contracts and about 1/3 by private sector investment. And we're learning to make rocket propellant to reduce the cost of activities in space. We engineers and scientists talk about getting around in space in terms of gravity wells. The hills that you see on this chart represent how hard it is to get away from the Earth, how hard it is to get away from the moon. And what our projections are is that for that $10 million for that gallon of water, we can make water on the moon to make rocket propellant out of for about 10% of that cost. And this will reduce NASA's cost for human exploration of the moon by up to a factor of 10 over time. And that'll make it possible for NASA and the government to build large scientific outposts on the moon, and for private sectors to start making cost-effective hotels. There are 250,000 people on the Earth that our economic studies suggest can afford a 2-week vacation on the moon in the economics that lunar resource harvesting will enable by the end of the 2020s. We've invented, as you know, as Roger said during the introduction, we've got about a dozen patents in the technology for harvesting resources from the solar system. Some of them are focused on harvesting asteroid resources. We're going to turn asteroids into gas stations in space to enable space commerce. So we see ourselves as the Standard Oil of the 21st century. And then we've also invented a way that we can use rovers to essentially vacuum up the water on the moon, collect it so it can be made into rocket propellant. We have a strategic partnership in a memorandum of understanding with Blue Origin. How many people know what Blue Origin is? Okay, so Blue Origin is Jeff Bezos' aerospace company. He spends some of his side cash, about $1 billion a year, on Blue Origin. They've got about 3,500 employees, and they're building giant rockets with the intention of building a hotel on the moon. We have a partnership with them, it's emerging, where we intend to sell them water and electric power on the moon. They're going to use the water and electric power to make rocket propellant, and they're going to provide us transportation services. So we're their gas station, they're our trucking company. And we do that with our lunar mining technology. So we're working on both the asteroid issue, which is eventually precious metals, but first gas stations to make it affordable to go mine those precious metals, and also the moon so that we can build outposts, hotels, and other industries on the moon. Now, it's easy to get water from asteroids. What you see in this test tube is a colleague of mine took a small sample of a meteorite made from the type of asteroids that we're going to be mining. You just take a few grains of that, put it in the bottom of a test tube, heat it over a Bunsen burner, and steam comes out. So we realized this several years ago, and we started working on the question of how to make rocket propellant from asteroid materials. And we'll talk about that in a minute. As Steve pointed out, the moon is only a few days away, but in space, we measure distance differently than we do on the Earth. We measure distance in terms of how long it takes to get somewhere, and instead of miles, we measure it in a parameter called delta V. Delta V is how much energy or rocket propellant it takes to get to a destination. So this map was published by a MIT professor named Rick Binzel in 2014. This is a map of the near solar system in terms of delta V. The vertical axis here is delta V. Most people think the moon is the closest body to the Earth, but it turns out in astronomical engineering terms, delta V, there are thousands of asteroids that are easier to get to than the moon. So these are little tiny rocks to boulders to planetoids floating in space, and they're the nearest bodies to the Earth energetically. So those are the ones that we really want to go to harvest rocket propellant so that we can be the oil provider, the Standard Oil of the space industrial revolution. Now, many of you learned in grade school that the asteroid belt is this region beyond Mars that has billions of rocks floating in space, say between Mars and Jupiter. Well, actually, that's called the main belt. The real asteroid belt extends from just a few times the diameter of the sun, really close to the sun, all the way out beyond Pluto. And so there's thousands of years and billions of targets out there to explore. So don't think of the asteroids as the main belt in the short term. The ones that we're interested in are the ones in the inner solar system. And the inner solar system, there is a collection of bodies that are called near-Earth objects, the NEOs. And at TransAstra, we've been studying a special subset of the near-Earth objects that are in highly Earth-like orbits around the moon. The Earth goes around the sun once a year at a distance of 1 astronomical unit. It turns out that there's a collection of neo-asteroids that are co-orbiting with the Earth around the sun. And those are the ones that will be the first targets for mining, for extracting resources to make the gas stations of the 21st century. So those are the ones that we've been studying very carefully. I actually started my career at NASA at JPL, spent about 14 years there, and left JPL in 1999 to go be a visiting member of the faculty at Caltech because space was getting really boring because it was government dominated. I started a program called NSTAR to fly ion propulsion in space. It went to, and the spacecraft that came from that was called Dawn. It went to the asteroids Vesta and Ceres. It only recently ended its mission. When I started that, I had a full head of hair. But a few years ago, a government agency asked me to look at SpaceX to see if they could buy a rocket. And I looked at it and I said, man, this is really great. And so I got back into the space business. The first thing I did was demonstrate the technology of asteroid mining. We've built a laboratory called the Asteroid Mining Testbed that demonstrates how we can use sunlight to excavate asteroid material and extract the means of refueling rockets. This is a little bit about our work in that area. We're building a spacecraft that we call the Mini-B that will demonstrate every aspect of asteroid mining. And it's 2/3 funded by NASA, 1/3 funded by private sector investment. The Mini-B, so we're building it in our laboratory right now. It's something that could fit on this table. We intend to launch it into space on a ride share on a SpaceX Falcon rocket in about 3 years. We'll launch the Mini-B along with a synthetic asteroid about the size of a beach ball. And to be lightweight in space, we use a lot of structures that are made of thin films and inflatable structures. And my engineers are fabricating this system right now as we speak. They're hard at work in my laboratory back in Lakeview Terrace, California. Uses an inflatable bag to capture the asteroid, and then you can see that robotic zipper. We use the same zipper that's actually built into astronaut spacesuits to close that bag. And then the solar concentrators, which are inflated, concentrate sunlight into the spacecraft and direct that sunlight, and the sunlight chews up the asteroid, extracts the volatile materials, mostly water. We also have patented a type of rocket engine that uses sunlight for power and water as propellant. We call it the omnivore. This is the internal structure of the Mini-B. Give you an idea of what it works. The way it works is once we chew up the asteroid, we'll separate the granular material, which can later be harvested for precious metals and so on, from the volatile materials that we make rocket propellant from. By the way, this is a draft of the video. How do you guys like it? Is it connecting? So I'll have to tell, so next week we'll be finalizing this video and posting it online. Now the Mini-B is just this big. The Honey-Bee will be the first operational system. It weighs about as much as a pickup truck. And it can go fly to an asteroid that's about as big as a single family home and extract a swimming pool's worth of water. Later, our Queen Bee system is about as massive as a fully loaded semi-trailer, and it will be able to go to bigger targets and harvest Olympic-sized swimming pools of water. And so the Mini-B and the Honey-Bee are the first steps. We're building those today. Now, we're also working on the moon. The question is, why the moon now? Back at Apollo, we didn't really have the technology to be sustainable on the moon. We thought it was a dry, arid body. We now know it's loaded with ice, probably 100 billion tons of ice. But we have to solve some key technical problems. How do we get power on the moon? So we've invented a technology called the sunflower, which actually allows us to put megawatts of power into dark craters on the moon that the ice is frozen in. And in our partnership with Blue Origin, one Blue Origin rocket can deliver a megawatt of solar power to the moon using our sunflower technology. And we've invented a type of mining technology that will build into our Beetle rovers to extract that water And this is a video of what we were working on about 1.5 years ago. When Jeff Bezos saw this video, he said, their vision is the same as ours, let's partner. And so he asked his team to partner with us. So the concept here is that first we'll fly our Beetle rovers to the moon. First thing will be a subscale Beetle rover about the size of the Mini Bee that will be flown to the moon on a Blue Origin lander to demonstrate the basic mining technology. Then we'll start flying the sunflowers to the moon to get the power for mining. And what we've shown is that a single rocket can deliver a sunflower power tower to the moon. While you can't make a tower 1 mile high on the Earth, you can make a self-erecting tower on the moon 1 mile high, which is an amazing thing. Because it can be 1 mile high, it can go up into perpetual sunlight from many, many places on the moon where we know that there's water. Once we do that, then we'll deliver our full-scale Beetle mining rovers to the moon, which will be 5 meters, it's about 17 feet in diameter. We can put 3 to 5 of those on a single launch vehicle. And then the sunflower will power those rovers. By the way, one of the things that you have to do on the moon is you have to make landing pads. If you don't make landing pads, then the rocket plume from when you're landing will actually send debris, hypervelocity debris into orbit. Some of that hypervelocity debris will come back and hit your lander, or be bombarding your base for months to come with hypervelocity bullets of debris. Now then, what we did in a previous NASA-funded study, and they're continuing to fund us at higher levels, is we showed how we could use these technologies to build what we call a lunar polar mining outpost that could grow from initially a gas station and a power station on the moon. You want to put those in place first. Then you can start to build habitats, and we can build those habitats so they're comfortable hotel-like accommodations. Now on the moon, you have to live underground because of the radiation environment. If you're going to be there more than a couple of weeks, especially for the general population, the radiation is very harmful. Which brings up a point. When we go into space, we have to think very carefully about bioethics. So what we're doing is we're developing the technology that will allow government outposts to then grow into commercial hotels that will then allow us to build industry on the moon. Jeff, now here's a question. Is it ridiculous to build a hotel on the moon? Well, the wealthiest person in human history has said that that's why he started Amazon, to do that. And he's investing his side money of $1 billion or more a year to make it happen. It's a realistic business prospect that may blow your mind, but there will be people in this room who will fly into space commercially within the next couple of years. So what do we need to do from a policy perspective to maintain the initiative and take advantage of this opportunity? Right now, space is a $450 billion annual industry globally. The projection is it's going to grow to about $2 trillion by the end of the 2020s. In order for the United States to maintain the initiative here, we need to develop the ethical and legal frameworks to make it so that it's not a food fight that begs for a war. We need to move strongly away from traditional government contracting with the big aerospace companies, which are simply not cost effective, to real private sector entrepreneurial companies, and the evidence shows that they're at least an order of magnitude more cost effective. NASA and the Air Force have both made important inroads in that. We all saw two NASA astronauts carried into orbit by private sector vehicle recently. This is the wave of the future. We need to think big and act fast. There was recently a workshop to discuss lunar initiatives. And NASA was thinking about putting a little hut on the moon that could handle 2 or 3 people with harvesting maybe 10 tons a year of propellant. SpaceX got there and said, by the time that you guys are doing that, we're going to be harvesting thousands. We need thousands of tons of propellant a year. And so the way that we're thinking at TransAstra is that kind of scale. We got to think big or we're going to be left behind. So that's all I have to say. Thank you.
If this is the future, what are we doing today in America in preparing the next generation to make this happen and continue?
Not enough. In my opinion, we're failing. The university system writ large in this country is not being effective in preparing our next generation of scientists and engineers. I recently had dinner with the dean of a major college of engineering with 10,000 students, and it's a highly rated school. And he's got 2,000 faculty members that work for him. He told me he doesn't believe in meritocracy. And what we need to do is work them harder and stop coddling them. In my company, our engineers are about 10 times as productive as a typical NASA engineer. The reason is we let them use modern engineering tools. We don't constrain them with rules and regulations and procedures, and we get out of the way. And I challenge them every day viciously. And you know what they do? They rise to the occasion. I'll give a young engineer a job that should take 2 weeks, and he'll come back, and I'll tell him it's due Wednesday, and he'll deliver. It's amazing what they can do. The bad news is we're not doing much for them. The good news is we don't need to. The main thing we need to do is get out of their way because they can teach themselves. It's no coincidence that Elon Musk dropped out of school, and many entrepreneurs did. You know, I got a PhD from Caltech, but I don't really believe in PhDs very much when it comes to getting great technical work done.
I'm just wondering what role artificial intelligence, autonomous vehicles, robots, things like that will play in this future, because it seems like we're right on the cusp of some big breakthroughs there.
TransAstra's asteroid mining vehicles are all robotic. I had a conversation, I helped Jeff Bezos structure Blue Origin in 2000. And we had a conversation then on what is the role of humans in space? And the answer came back, recreation. Terrestrial robotics and AI are light years ahead of NASA robotics and AI. At NASA, when the rovers go on the moon, you know, humans plan the trajectory of the rover days in advance, you know, and they go, the distances they go per day are measured in yards. Terrestrial robots, if we apply terrestrial robotics to that, the rovers can completely take care of themselves. So that's going to be absolutely critical. But AI is like water. It's a utility. It's a very important emerging area, and space will capitalize on it in a big way, but it will not drive it. The pilgrims came here electively. Most of the humans that go into space will go electively. You know, it was pretty crazy in Europe when the pilgrims came here. You know, it was during a time when the ideas of the Enlightenment were being promulgated, but they were still run by a monarchy, and the Enlightenment actually hadn't happened. We're in a similar time of social foment, and I believe that social foment will drive millions of people into space in the coming decades, in the same way that it drove them to the New World. Hopefully we will do it on a better ethical and moral foundation. And that's going to be, if we're going to be successful in space, there are technical problems, there are business problems, but given the social foment of our time, if we don't get the ethics and morality right, the collective wisdom of the world will actually, I think, prevent it.
What I'd like you to think about and talk about, if you could respond, would be the societal benefits of the science that's going into space exploration and how it can benefit society.
Yeah, so you're talking about the concept of spin-offs. The idea is that you develop space technology and that it has other applications. I'm a contrarian. I think that it's more efficient to just develop the technology for those applications. Spin-offs will happen, but I don't think it should be a primary motivator. I think the primary economic benefits back here on the Earth, as Steve said, will include ubiquitous power. You can harvest gigawatts of power per square kilometer in space and beam it to the Earth. That'll be tremendous. Elon Musk is building a constellation of 30,000 communication satellites that will move the internet backbone into space, and that will restructure the world economy because right now, the telecommunications industry has a stranglehold on the internet backbone. That's going to be profound. It's also going to put high bandwidth communications everywhere on the planet in the third world, and that'll make it possible for them to industrialize much faster. So those are a couple of, so that'll be the first near-term, mega trend that'll be changed by this process. As we start to harvest power in space more effectively and harvest the asteroids, it makes a lot more sense to do manufacturing in space than on the ground. So we'll build robotic factories in space. As outlandish as this sounds, and it's a huge paradigm shift, so I don't expect you to believe me on the basis of this claim, but if I had 5 hours with you, I could convince you. We'll be manufacturing goods in space and exporting them to the Earth. So the self-driving car that you drive in 2035 will probably be manufactured in orbit and made out of asteroid material. So, and manufacturing will become as cheap as ones and zeros at that point. The factories in space will make copies of themselves and any goods that you need. So, as I said, it's almost impossible to fathom the resources that are available in space. There are 1 billion asteroids. There's enough material there to build worlds where you can live in comfort, in a beautiful, inside-out, outdoor structure, and with 1,000 times the carrying capacity of the Earth. So the long-term potential is off the scale. I think a lot of the social unrest that we see today is because we've raised a generation of kids and told them that the world is not going to be as good in the future than it was in the past. The technology that most unleashes economic potential is philosophy. If you have an optimistic philosophy, you believe that you can do anything. If you believe in an unlimited future for your children and their children on into the indefinite future, that the world is getting better and it will continue to get better, there's a sense of optimism that you bring to the table. If you believe that we're squandering the resources of the Earth, it's a fixed-sum game, we have to fight over the resources, the only way to get ahead is by wealth redistribution, it's fundamentally a negative attitude. And so I think the greatest economic benefit of space will be optimism. America was a city on a hill. It was a shining beacon of freedom that caused freedom to spread throughout the planet. Space can be a mountain, a city on a mountain. And the beacon of freedom can be much more powerful in space than it was on the Earth. And it can be the thing that really saves our species if we do it right. Imagine a true private sector, entrepreneurial, space civilization. Let's build a city in space which recognizes the rights of the Enlightenment, free market, rational regulation and law, and show what people can really do. I think that would be incredibly powerful.
Tell me what cost effectiveness, cost benefit. I could see defense for satellites. We don't want Chinese satellites blowing up the US grid. But what's the cost benefit of going to the moon for aluminum?
The only reason you go into space for resources to return to the Earth is if it's more cost effective. If we had more time to talk about it, I could explain that the really valuable materials on the Earth are all in the core of the planet. We can't get it. Impossible. We'll never get it. But those materials, think of the asteroid belt as a planet turned inside out, where all the really valuable stuff is just right there for you. Also, there's this, as Rand was saying, space travel is, right now, it's very expensive. But actually, there's no fundamental reason why space travel should be more expensive than air travel. So, and we're getting there quickly. It's a massive paradigm shift that will take a while for people to get psychologically. Once we get it psychologically, it'll happen. But as space travel becomes as cheap as air travel, it will make a heck of a lot more sense to harvest our resources in space than on the Earth, because it will be cheaper.